Hello, everyone, and welcome to this September edition of the Community for F# Hangouts. This is Ryan Riley. I'm happy to present today, or I'm not presenting, but Henrik Feldt will be presenting today Suave from scratch. We're excited to have him. If you're interested in learning more about Community for F#, you can find us on GitHub, Twitter, Vimeo, make sure to spell it correctly, the web, and on YouTube. We have several channels for videos. This one will be available shortly after the presentation. I'd like to introduce Henrik Feldt. He has been working on Suave with Ademar Gonzalez. Suave is a web framework, and he'll be showing us how to get started from scratch building a chat client. So without further ado, I'll hand it over to Henrik. Thank you, Henrik, for joining us, and we look forward to seeing what you have to show us today.
Thank you. Okay, cool. So I suppose this means that you can hear me. So far, this is the first Hangout that I've run, so I'm not really familiar with it. I'm going to show you how to do Suave from scratch. Okay, thanks. Good. I sound great, it says. Yeah, so let's get started. I'm going to start by showing you my screen, my desktop here. There you go. Okay. And here we go then. I have a few different modes. And right now I'm going to show you the introduction. So that's not going to be the very fast mode, but rather walk you through how Suave works from scratch. Here is our beautiful homepage, courtesy of Ademar's company and designers at his company. I'm going to suppose that you already have your environment set up, meaning you can run NuGets, you can run executables, you can compile them, and so on. Otherwise, I recommend Xamarin Studio, and that's what I'm going to present on today. Also, I recommend using Paket. Paket is a package manager which pulls in packages from NuGet, and this is then how you get Suave. So I'm not going to go directly to Hello World, but rather I was going to show you how HTTP requests work, in particular this one. And so I'll create a new page here to show you in. And then I'm going to improve this font size a bit. So because I've already referenced everything using my packet.references file, as you can see here, I can just do open Suave. Suave comes in a couple of modules. The most important module being HTTP, because that's where you find all of the applicatives. You find all of the pieces you need to build web applications with Suave. So the first thing I'll show you is this one, the web part. This is defined in Suave.types. So when you start a new site, you often open Suave types, Suave, and Suave HTTP. You can see the declaration of web part. Web part as a concept of its own is important to realize is easier to think about if you think of it as its own thing. If you think of it as a function like this, it's slightly harder to reason about. Because if you want to do something, let's say you want to send an OK back. You can see in the documentation that it takes a string and returns a web part. So the most important thing to think about and to focus on when you compose web parts with Suave is that they're all web parts. And as long as you can find something that types to a web part, i.e. something which compiles when you say that it is a web part, such as this thing. Yeah, you can see there are no red squigglies. You're fine. And now if I wanted to push this out as a web server, I could do that because it compiles. With that said, let's have a look at the hello world. You can see I pulled in from successful, that's a module. In F# you can also do explicit opens of modules. That means that you place all of the functions in that module in the current context that you type in this case, the sample module. Should I then paste this, I now have a web server. I'm going to show you the actual running file later here. This is just for explaining the basics. So I'm not going to start running a web server right now. Or am I? Let's run the web server. Reconsidering that. If you want to run something, then in the interactive, you need to add it. So if you add this thing as an interactive thing, you can compile this as an application. But if you select everything and press Control-Enter in Xamarin Studio, so you're sending it to the interactive. The thing here on top means that you can make the file executable on a Unix system. And if you do that, you can do, if you got the bash, you can do showcase.fsx normally. We're going to remove that and just reference the Suave package. There we go. So I'm currently in a folder, which means that if we have a look at it, you can see the Suave presentation one is the main one, and I got the SLN file, but the file here, the FS file, is in a subfolder in source and site here, which means I have to go back twice to reach packages. If I do, you can see in the interactive that I get proper output. Let's reset it, retry it, and you can see that I now have reference to Suave. I made a mistake when I upgraded to F# 4.0 in the Suave library, because when you write a library, you probably want the lowest possible F# version that supports your use case. That means that because the interactive is compiled with F# 3.1, I had some trouble setting this demo up, which is also why I'm going to show you as a console application rather than an FSX file. You don't necessarily notice it directly, but you may get missing method exceptions. Loggery, similarly, is compiled for 4.0. So I'm going to use that in this console app as well. Suave is the only thing, obviously, that I need to reference to run Suave. And that means I can now execute these lines and spawn the server. With the server running, I can go to a shell of some size. Let's clear the console. And I can do curl with the endpoint of the server. So we got hello world, amazing. Then you can also see then that Suave is the server that serves, and you can see content type and content length. We could actually change the content type to showcase how that's done. And I'm going to show you this operator, which means take everything on the right-hand side evaluate it, and then pass it as a parameter to the left-hand side. So this is equivalent to what I just had. Now, this means that I can use something called applicatives. That's just a word for now, to compose my web app. So say I wanted to tell my requester, this thing, curl, that I have UTF-8 as the char set. I could do that using this thing, the operator bind. So then I need to open something else called writers, and then set header type. Actually, there is a set mime type, so I'm going to use that. And that's text, plain, UTF-8. And let's run that. I think I need to reset this thing, because this function is blocking. That means that it won't yield control back to the interactive until I either reset it or cancel the cancellation token. But since my interactive is frozen, waiting for the web server call to complete, I can't call further cancellation tokens. That's why there is this async thing, but that's slightly more complex, giving you options to both wait on the start here and wait on the finishing if you cancel the requests. So let's stick with this one. So let's run it again. I need to reference Suave and make a request. And as you can see, I've now changed the content type header. So that sort of gives you hello world with Suave. Of course, this is nice when you do scripting, because you can spawn an asynchronous web server, continue with your script, for example, with fake or albacore, and then terminate the server when you're done. With the cancellation token that you find. The default cancellation token, I think we have being the same as the async cancellation token. So yeah, that's hello world. In this module, the HTTP module, there are a couple of different niceties. I've shown you the OK so far, and I've shown you a different module as well, set mime type, and how to compose. You notice it didn't take very long to get to this point. But of course, it's not enough to get to this point. You actually need to combine to make routing possible. You need to combine to make other things than get possible. For example, you might want to do a post and not just get the same result without anything happening. A few core concepts then, one of which is the HTTP method. They're known, but you may also define custom ones, for example, if you're implementing WebDAV or you're implementing a more exotic protocol that runs on HTTP. What I've shown you is get and post as seen from the client here. On the server, however, we may want to choose different web parts, like this one. That's a web part. That's the thing I went through previously. Depending on what HTTP method that we come through. So if we come through get, for example, we might want to show hello world, but if we do post, we want to say that we've successfully saved something. So let's showcase how that works. The type here, HTTP method, is defined in this namespace and module. However, we want to use the HTTP module to compose the control flow of the server. And the core part you need to use to compose control flow in Suave is called choose. So with choose, we can now extract the OK web part. I can show you that it's a web part by just annotating it. And then below that web part, we can do other things like responding with saved. Now, there's nothing that tells the server that what we got up here shouldn't be matched, because that's how it works. The choose applicative, the combinator, it takes a range or a list of things, web parts, and then lets you match certain things, change the results, such as this one, the OK, from this module, successful.ok. It takes a string, and then it returns a web part. This thing, it takes a string and returns a web part. So the two of these are combined using the bind. So let's see if we can reach this one now that I've made a change. And let's remove the stuff we don't use. You can see I can post, I can put, I can get, and so on, but we never get the saved. How do we get the saved? Well, you can see things that just change the output, they always match. And that's the core concept. If we use an applicative, though, we can combine web parts that don't match. You can see it's the first module under HTTP. So we may want to say that when we get, then we respond with this web part. Of course, this in itself is a web part. And of course, this thing is also a web part. You can even format this to make it easier to read. Of course, because the compiler knows it's web parts, you don't need them. You don't need to be explicit. Being explicit, that's nice when you create helper functions that take something and return something. And you may want to say that it's a web part, meaning it has the signature Come on. Fail. It has a signature that I showed before. HTTP context to async HTTP context option. And so in this case, we've used something called fail. So fail is the result returned from a web part when you don't want a web part to match. Let's see if we can use this thing to fail the matching of this one. Fail, as I said, is the result. And since a web part is something that takes a context and has a result, fail is that result. You can see it's an async HTTP context option. So after the get, and here is another nice combinator. It's called a request that gives you the request here and expects you to return a web part from your function. And when you've given the function, the constructor function here, that does the logic, it just outputs that as the web part. Let me show you. At this point, we don't need the request, so I'm just going to underscore it and do fail. How does that look? So it's expected to have type HTTP context to the result, but here it has the result type, this thing. So the error message is telling me I need to return a function from HTTP context. And that was to be expected because when we hovered the request function, it said, please give me a function that takes a request and returns a function from HTTP context to the result. Or in other words, please give me a function that takes an HTTP request and returns a web part. And because this thing, it was the result of a web part, we need to wrap it in a function to make sure that it works. I promise you, this is the hard part. Once you wrap your head around this, it's very easy. And here you have the request. We can hover them and we can see this is the request. Here you got the context, and here you got the result. That never matches. So were I to compile this, sorry, not compiling it, were I to rerun this thing, I should be able to get saved as the result using curl. Yay, I did. And that was because this matched, this web part matched, this web part also matched, and these two wrote contents to the result. However, when the context that these two changed and this one matched, but they all three matched, was given here, the context, I chose to fail the web part. And that means that the chooses the next one. Okay, but that's not very realistic because we probably want to say that if we come with a path of /, for example, we get that path, then we should respond with hello world. Otherwise, we want to respond with saved. So that's more idiomatic. But now you know how web parts work. And again, that's the hardest part about Suave. It takes about 10 minutes to explain. Running it again.
Henrik, may I jump in with a question?
Yeah. Sorry.
Here, oh, no worries.
Yeah.
I see that you're mounting up a path underneath an HTTP method. Is it possible to do the reverse and have a path at the top and have the methods stacked underneath?
Yeah, absolutely.
Okay, very cool.
So they're commutative. You can choose any order you want. Every web part outputs its own HTTP context. The thing you saw when we used request. Yeah. So that was the result thing, and the thing before, the context. That's the same value that comes in. So the context comes in here, matches path. Path doesn't actually change the context anything. Neither does get. This thing, it writes to the context. And when I say it writes to the context, I mean that the response here is filled out with an HTTP content. That is hello world. So if I wanted to recreate this thing, I could do it like this. Did that work out? So let's type check it. I mean, the compiler already is happy, but it said that the result should be a context. Oh, okay, the error was out here. So it's telling me unexpected symbol. I can't type properly. Let's do a bit of formatting. Okay, so that's better. We could do like this. You can see why we got applicatives to do this. So it seems like we had one too many. Right, so the context here. So now it's telling me that this thing was expected to be of this type, but it's just of this type. So we need something that takes this thing and wraps it in a sum. So we want some HTTP context, where we got an instance or a value of HTTP context, and we want to place that there. So I've shown you failed previously, or fail, and now I'm going to show you succeed, because it takes a T, like I just shown you. So there we go. And I get an indentation error, and there we go. Awesome. Let's see if it works. I can build. I can reset this thing. I hope I can run it. And let's see, I should now only be able to get hello world on slash. I could. Oh yeah, but I haven't changed the response code. OK also sets the response code, meaning yeah, the status. Sorry, I used a bug there in Xamarin Studio to show it. So the status is something status, maybe. Here we go. Normally, when I want to find something in Suave, I don't consult the documentation, but instead I just sort of dot myself through the modules. And you can see that it should be fairly well documented. I haven't been able to find that many things which don't have documentation. So we should respond with 200, we're saying here. We should then run it in the interactive here. Try it out. Hello world, and the correct response type, or a status code. Awesome. So that means we now know webhots. We know applicatives like get and path. We know fail and succeed. And we know about bind. We know about choose. So what more is there to know about? Well, sometimes you just want to get the context directly, and you don't want the request, because as you can see, we don't actually do anything with the R. We just let it go. And there is another function that has a funky signature, and it's called warbler. And the summary here is pipe the request through to a bird that can peck at it. Put another way, using warbler lets you look at the first parameter and then make a decision about what thing to return. Most likely a webhook then. And then remember, because when I was a newbie in Suave, I went through the code base and tried to document what I kept forgetting. And this is what we got to show for it. And you can see that it's T to T, so it takes, well, I'm just going to use it. It's easier. Maybe here. I told you we didn't need the R. And now it's telling me that it's expecting a function from context to result, but given a context to result. And that means we got one context too many, I suppose. And that's because we're using succeed, which, if you remember from a few minutes ago, was just wrapping this thing inside of the result. So perhaps it works if we just remove it. And now it's telling me it was expected to have type of HTTP context to HTTP context. Okay. The reason for this is because the warbler function lets you compose other web parts. So let's say you got a function that takes some message, and it is a web part, so that we should be able to compose it using bind. Then we may need the context to give input into the message before we call it. And that's the little bird pecking at it before we pass it forwards. So let's see if we can refactor this code to be useful. So we wanted something for the message. Let's say we wanted to get something from context. Let's see what we got. We got the connection IP address. Awesome. Let's output the IP address. And the composable function then takes a message. Now this compiles, as you can see. And that's because, again, we pipe it through the function so that we can use the context before we create, basically factor this web part out. So we can now use it to give this web part messages. Finally, we have the problem of context here showing red squigglies because it's not defined. Now, we could either say, OK, message, and be done with it, or I can show you another very usable pattern once we have this annotation on the method, which is, if you again look at the web part, it's a function itself. So just by declaring an anonymous function, we get access to it. See if I was correct. Yep. But now it's expecting the result type again. So let's give it with succeed, which had the signature again. Give me a T, and I wrap it in the Suave result thing. Or we could do OK message. It's up to you. So that sort of concludes the basics, the foundation. And with this, you get a very, very strong sense of what you can do, because as you can see, you can modify anything about the response. And you can even, which we're going to show in just a few minutes, pipe streams and do things on the fly without getting all the bytes before as a part of the composable function web part. I'm going to show you a chat example later. Null content, that's just a sort of null pattern. It's a default. So you normally only use bytes in socket task. And bytes you only use if you have contents which are binary. Otherwise, you tend to use the ready-made web parts. And if, again, you want to find them, just go to HTTP and press full stop. And you'll get all of these different modules. So I've shown you the stuff from applicatives, applicatives being things that match. And if they don't match, they pass it on. We also have stuff for basic authentication here. And if you want to do something other than basic authentication, I recommend that you use the library called logibit-hawk, which implements hawk authentication, or rather authorization, inside a Suave web application. You can see, again, I compose web parts in the same manner. You got control. That's probably not something you want to touch if you're a beginner. embedded, which is stuff you can use to fetch resources from the assembly and other assemblies that you may be using. And that means you can compile in static resources and content into self-contained web servers, which you then run as a part of your, I don't know, C# app, F# app, or even manage C++. With event source, you can do push to the client. I'm going to show a case of that. You also have the global things like fail and succeed, and never, actually. Never is a web part, but fail is a result. So I could have used never in this case with instead of the request. And then this part would never be matching, and this would always be returned. We have redirection, redirecting the browser, and you can see here the documentation comes from the RFCs. Now, if you wanted to say not modified, you can read about what the RFC says about not modified. I find this useful because it's not always you have the RFC next to you when you try to create web APIs. Another thing to mention is that you have lowercase things like found here and uppercase things. So I'm just going to save that for later. You can look them up as well in the source code. You have request errors for XX class, response codes, response itself, which is a module these other modules call into, server errors like bad gateway timeout and such. Useful if you want to proxy something through Suave. Successful, which of course is accepted, created, and okay, and no content then. And you got the writers. Writers are useful for modifying data values in the response, like headers, mostly. But you can also do set user data and unset user data. User data being something you find in the context.userState. In the user state, you can save things going forward. So you might want to use the composable function to save something. Like this. Now you'd be able to access sample inside the warbler. And now it's not typing because it's telling me I should return a web part. So that's the user state. Now you can pass values forward. Very useful if you match and add some metadata, like an authorization context, and you want to use that authorization context later. And that sort of concludes the HTTP. We've gone through most of these. Great. That gets you quite some way into being able to use Suave for actual web APIs. Now, what I want to show you is the files module, but I'm going to show you how to use it as a composed web application. The reason for this is that we have approximately an hour to have this presentation, and I can't show you how to develop all of a web application. With the knowledge you've gained here, you can pick Suave off the shelf today and start using it. You should be able to get up and running with a hello world in just 10 minutes, and then let the IntelliSense guide you the rest of the way. But I do want to show you what's possible with Suave. Also worth mentioning is that Suave is the thing I use for my own company, Kvitu. I don't know if you can see me right now, so I'm going to show you this instead. Let's stop the screen sharing for a second. So here is Q2. It's the company that I work for as a CEO. You can find us at q2.com. Now let's get back to the presentation. All of our stuff is written using Suave and also using Logibit Hawk. So then, with the showcase done, compiling, yes. I want to show you how you build a slightly more advanced application. You can see I have the same stuff at the lower bottom here of the example application. And the example application is available if you go to currently my own GitHub. We're trying to make it build on Heroku. And here you find all of the stuff ready for your perusing whenever you want. So, start web server. Again, we compose web parts, and putting the different sections of your site in different modules is very useful. So you can see here that I've moved the chat API. So what I want to do is build a chat server. So I'm using choose to either select on the chat API, or if the API doesn't match, I just want to use Suave as a file server. And I then use http.files to first see if you can find the file requested in the home folder. And that's something you configure when you start it here. And then if I cannot find the file, I can just serve the index.html file by default. The reason I do it like this is because when you write single page applications, you probably want to be able to navigate to any sub-page, any sub-view of that application. And you want the web server to respond with the same file for all of them. But you don't want to keep updating your web server code every time. So all you have to do is serve the same file unless you can find the actual requested file, unless you find it as the API. And then let the JavaScript take care of the rest. I normally also put this thing at the end because please place your index.html file in and then some home folder is a useful error message to get when you're up late and you just need Suave properly compiled together with your website and published. Then it's nice to get some help instead of a hanging request, which you'd get otherwise. So always have something here with just plain text that doesn't depend on some state, which this thing does. Let's have a look at the overview of the API, the chat API. You can actually see it up here. Chat, the module, starts fairly high up. But the initial thing I want to show you is that I set the MIME type for all of these web parts as application JSON using a charset UTF-8. Both of these things are important because normally when you have an API, you don't want to speak anything but JSON. And you normally don't want to speak anything but UTF-8. So I make sure that this web part always matches before I go into the choose thing. And that means I don't have to redefine this thing for every single line inside of my API. Of course, it doesn't work well here. So I only do it for the API itself. I have 3 operations in the chat API. I can send messages, I can read all of the history, and I can subscribe to future messages. I told you previously we were going to have a look at event source and how that works. Event source works by performing a handshake with the browser. And with Suave, it then hands off to fcont, a continuation that allows you to return your own socket operation that can then send data to the browser and the client which did the request to this web part. In this case, we use a hub and spoke pattern, meaning one user can multicast messages to many. And when you do a get to the subscribe path, you subscribe the user to the hub, because the hub is where all the action is. The messages part reads history, and the chat part takes some data denoted by the utils.deserialize, which we can have a look at up here. You see we take the request, we take the raw bytes of the request, we pass it as string, we pass it as JSON. So this gives me a JSON object model back. I'm using a library called Chiron here by Andrew. It's an amazing library. So given the JSON value, the object model here, we deserialize it into some type denoted by whatever the function takes. And then we pass it forward to the function. And then that should return a web part, because request should take a function that returns a web part, as you can see in the second two arguments of f, or the second argument and the result of f, rather. That's a web part. So this returns a web part, which means this is a web part. And it all type checks. So deserialize means that we can give it a function, fn, of some a, and then have that thing return a web part in the end. In this case, we want to broadcast the message to everyone listening and subscribing on the hub. Once we broadcasted it, in this case, we're returning a unit, so we urgently need to give something more than unit back. That's why we pipe or we compose the broadcast function with another function here that just gives us created back. Created being a web part in the successful module, like such. And because I'm telling the API consumers that I'm always returning a JSON, I return a JSON string in this case, but I didn't feel like actually serializing it. The read history thing is done using an API, wrapping API around the hub that gives back an asynchronous workflow or value which contains a sequence of messages. I take all of the messages, make them into an array, and then serialize and format this as JSON. You've previously only seen web parts which are connotated like, or annotated with web part like this. But you can also declare the context as a parameter to the function. With read history, all of the read history thing is a web part in itself. So I could potentially do web part equals fun context and arrow async. And that would mean exactly the same thing. With the async, again, web part means that you return something which is async HTTP context option. This thing returns a web part, which is, again, HTTP context to async HTTP context option. Because this thing is the web part. If we give it the context, what do we have left? Well, we have the async HTTP context option. And because we're in an async workflow builder, we can just return from that builder, unwrap the async, so to speak, and give back the context option. And that then matches the signature of the web part up here. We can also see that we create a single static global hub for the whole process. Okay, I'm going to show the JavaScript and how I've set that up so that you can from this video, get a complete workflow of how to create websites and web applications with Suave. Just showing the server sides doesn't necessarily give you the tools and knowledge needed to write full web page applications. And while this isn't a JavaScript app or a JavaScript presentation, I still want to show you how it's done. So as the final cherry on the cake, maybe, I'm not a native English speaker, so I'm not sure about that. I'm going to show you how this thing works, which is quite nice, to be completely honest. But for now, let's show you the JavaScript. I also want to show you the thing running. So you can see I've compiled a few times over and over again. Now I can start it properly, and I can show you the JavaScript. In the sample repo that I linked to you previously, you can see that I've created a docs folder with the steps I took to create this site. And you can also do a log to see exactly how I worked through and to get this working, the chat itself. But for now, let me show you the JavaScript. So in this case, I got a public folder in the as a sort of direct child to the presentation site, and it's running npm. I'm calling, corny enough, the application MaxStreamy with a description. It's MIT licensed. I put in some nice dev dependencies, which you can just steal right off the bat. These give you a nice linting. It gives you ECMAScript 6. It gives you a unit tester. It gives you CSS loaders, stylus loaders, Webpack itself. Maybe many of you have started using Gulp and Bower. But the problem with that is that you first have to install Node, and then npm, and then Bower, and then Gulp. I think I got that in the right order. But you can also, which I prefer, just use npm. So you just have two things to install. And then you put dependencies on whatever you need. In this case, I'm using React. And I'm also using a few other things. I do npm install to download everything. You can see I got a task called install, which also creates the build folder here, copies the index.html file and such, and then makes sure that I've compiled everything, all of the JavaScript I need, into a single file, also outputting a mapping file so that you can debug down to the correct line of code in your browser. That's the output. And in the JS folder, you can see the map file. So besides that, we got the CSS, which has a stylus, a very nice way of writing CSS without all of the annoying punctuation. We don't have that much in there. And then we have the JavaScript stuff. Because it's a sample application, it's not very large. We're going to use React, as we've shown previously. And we're also going to use something called RX React. React in itself is fairly reactive, but with RX, it's even more. RX is Anders' project with from Microsoft, and it's called RxJS. Let's have a look at simple implementation of something reactive using RxJS up here and React and Rx React. So this is standalone, and this thing combines the two into a nice mixing. And that means that you only need to do get state stream instead of get initial state. And from here, just output your state, whatever it is. And then if you wanted to get rid of get initial state, you can do let's start with. And now you always have a state. So you can remove this as well. And there you go. You can see I'm using the ECMAScript 6 way of writing JavaScript, which gives you nice things like pattern matching or destructuring, I guess. However, that said, the main chat application is in index.js. And before I show you what the code looks like, I want to show you what it looks like in the browser so you know what to expect. Here we got the Chrome. Web page not available. 8083, obviously. Right, so it seems like I'm serving our example file. Let's remove the showcase file. We don't need that anymore. We just need this thing. Small mistake. Now I should be serving on 8080. Yes, great. So let's move our web apps over. You ask me for the name. I'm Huff. It is true. Below here you can see that it's sending a post, getting an ACK back, and then subscribing and getting the message as a server-sent event. Not too bad, eh? Here you can see it's the first event. Now I should be able to open up another browser, which I happen to have here. Not that one, but this one. So let's say that was the Huff one. Huff says, and now I'm Adamar, and I can do really. You can see that we got pushed from Suave to both windows at the same time. And there we go. We now have a chat. The last 2 minutes, or maybe I'm going to go 5 minutes past, I'm going to show you how this chat works from the JavaScript side and the F# side. I'm using something called Material UI, which is Google's new style of writing GUIs. With RxJS, I create subjects to publish changes on and streams to react on. And then I create the states string. This is for the first page, this thing. And so it's listening to submit, subscribing to it, preventing a post, and then saying handle name, invoking that function with the name itself. The second view, the chat thing, contains of a log, and the log is just a definition list with deep T and DD. It takes as props a list of messages, which it then maps over. I also have a factory function for the DTO chat message for when I'm stubbing. The view itself, where I chat, is this thing. You can see that I'm listening to both typing of values, which I then, I'm not going to be able to explain everything here, but basically we also stop postbacks, we show what we're typing, And here we bubble the event or the value to handle says, which then the chat app later down, composing the above, handles and sends to the API itself. And the render is a rendering of the props, the data itself coming from the above, the app, which is the parent of this child. So it's matching out the username and the messages. And the state, the type text, is something that we want to display here in the text field. So the handle typing, that's the subject we've shown previously up here, which we then publish data into, which at the end flows out from typed text. And that's the app itself. The composition here, it makes the requests, makes a JSON request. If that fails, we try 3 times, start with an empty list, log a bit when we get things. Like here, you can see we log the messages and we log the initial response. And then when people start saying something, then we actually get it from the event stream or the event source using this one. Down here, we're composing the two. So we're composing the initial message request data with the event stream that we get from the event source. And then we scan it into an array. The event stream itself, or the React component, is done using combine latest of the name. So we know who we are, like I'm Uno at this moment. The view stream, which is state machine, or the chat view. So now something plinged here. I'm not sure what that means. Is that a good thing? Maybe Adama. I'm just going to finish this up. The boilerplate is the thing that makes sure that we get the nice themes and the styling. And so that's the full JavaScript application. In the other files in JavaScript, I have underscore and underscore RX, which gives me observables from the web requests, which is very useful because you can then create streams of these things, and RxJS will automatically know when to dispose of the observables, and you don't have to do it. It also can handle retries and such, as I've shown you. So now that you've seen how the chat works, how the JavaScript works with Rx, I'm going to show you a way of doing this from F# as hub and spoke, a pattern. Let's start from the basics, from atoms, and show you how message looks. This is the DTO we pass back and forth. You can see the DTO here. It's the same in JavaScript, and it's the same on the server for ease of use. This is the cheer-on syntax, and that means that we can parse. We can read stuff from the input, from strings and from JSON stuff, and then create an actual DTO from it. In this case, we can write to a JSON monad, and it gets turned into the object model of cheer-on. We're not using the control flow, so let's erase it. When I develop, I usually stub. In this case, I'm using the stub messages here. I also have history. That's the thing that you get when you initially load the application. Like if you're a new user and you say, I'm Ur, then you load it and you can see all the messages. You can see them here. That's what the history is implementing. And it's a very, very simple round buffer that I keep overwriting stuff into. And then I can just make that as large as I want. And no one can sync the server because I've already allocated the memory for it when I start the server. So the hub and spoke, that's the really interesting stuff that I tweeted about before we started this cast. And we have two things that we can tell the hub and spoke to do. We can either broadcast a message, and that's when we call post send, or we can read the history, because the history is encapsulated inside of the hub, being the singleton of the whole process. And this is just an ML-like pattern of encapsulating private state. It's deliberately annoying to type and understand because you shouldn't touch it. You should just touch whatever you get back from create, which is then T. And you shouldn't uncoil it. You should just pass it along like we do further below. I'm going to show you that. So with the create, what I'm doing is that I'm creating a server which is continuously looping. I'm also creating a channel on which I can send these commands. Here I'm yielding everything as the result. I'm spawning the server as a job on the global scheduler for Popac. And this is just looping recursively into itself. And whenever we want to broadcast something, we both create that as an item in the source of messages, and this is for the subscription, and we save it to the history. You can see history here is the container itself. That was the thing here above. And using modules in this way with create, you get a very ML idiomatic way of coding, meaning that everything is a value, but you still get very high performance. If we want to read the history, we read the history and reply on this channel, and then we continue looping. That's the main server, so it's really not much more to it. The subscribe function, here's the hub as well, pattern matched out, just as it is here. You can see I'm pattern matching this thing. You can see that it has a funky signature, connection to socket op. That's what we need in order to do event source handshake. You can see here that it takes a fcont that takes a connection and returns a socket op. And that's this thing. So the connection goes here, and the socket op, that's this thing. It's also a small loop. And then for every subscriber, we tap the source of messages, and then we read them all forward. And it's actually a linked list of promises. So here we take the next one, we wait for it, and when we got it, either we close the hub and we get nil, and we close the socket for the client, or we have some message and another promise of messages. Take the message, serialize it, and broadcast it. And then we continue looping. Finally, and this is the last part of this presentation, we got the history, which takes, again, the hub as an input. And as a result, it does request reply into the hub itself. This is the command channel that we called it previously. We create a reply channel that the hub can respond to. You can see up here that when we get read history, we get the reply channel. And then we make an alternative out of it, and then a job, and a sync, because that's the adapter that Suave needs. And yeah, that's about it. That's how you write a multi-threaded concurrent ML chat server in an hour.
That was fantastic, Henrik. Thank you so much for presenting that.
Thank you.
I'll give a little bit more time. If people have questions, please feel free to ask on Twitter. You can also use the Q&A feature in the Hangout if you're watching. While we're waiting, I'll go ahead and present a few last-minute things here. First up, there are several conferences coming up soon, and I'll show those real fast. So if you go to lanyard.com and look for F#, you'll find a number of them. The ones coming up very soon in Europe, F# and functional programming in finance that Tomas Petracek is going to be presenting. And then in mid-October in New York City, F# Gotham. There are, I think I saw on Twitter a little while ago, 10 early bird tickets left. So if you hurry, you might get a spot there with the early bird pricing. Coming up in November is Code Mesh and Build Stuff. And then December is Fast Track F#, Progressive F# tutorials. And then early next year, we've got Code Mesh coming up and F# Exchange in London. So if you want, please check those out. Also, I'm excited to announce the Community for F# Heroes for 2015. Thank you for all of you who nominated and voted. Everyone, I just want to make sure to point out that everyone who was nominated is certainly worthy of the award, and this is not in any way meant to lessen the impact, but we picked the top 5, and they will be getting a mug in the mail soon as I have your addresses, that is. And so I'll go ahead and announce them right now. The top 5 vote getters for the Community for F# Heroes were Chris Holt, Dave Thomas, Scott Voloshin, Stefan Fortman, and Tomas Petracek. So congratulations to all of you. Matthias and I have been talking about a few things with respect to this, and one of the ideas we have is to actually have some short interviews with each of these winners to get them to talk more about what inspires them and what drives them to participate in the community, so you can learn more about the people that were selected. Also, going forward, we'll probably do a kind of a holding pattern so that those who have won in the past are not eligible to win in the future, so that we can kind of get around to more of the heroes that each of you have nominated and voted for. So we look forward to doing this again. And thank you again for all of your hard work, those of you who participate in the community, both who are new and old and have been contributing in various ways. So we appreciate everything you do. Henrik, I don't see any questions popping up here. But that was absolutely fantastic. I thought you did a really wonderful job covering both the basics and some of the more in-depth pieces, and I definitely learned a lot myself. So thank you again for presenting today. This video will be available shortly on YouTube. I'll send out the link over Twitter. So if you missed it or know someone who did miss it, you can point them to that. It'll be available on the YouTube feed that you can find from c4fsharp.net. And with that, thank you for joining, and we'll hopefully see you next month. Thanks again.